properties of parallelograms here. Before we start talking about the different properties that go along with parallelograms, though, I got to make sure you know what a parallelogram is. Can anyone tell me what a parallelogram is? Yeah. Yeah. Has parallel sides, okay. Both pairs are parallel. How many sides does I just told you how many sides it has. A parallelogram have? 4, right? It's a quadrilateral. So a parallelogram, by definition, and this is my shortening of parallelogram, okay? A parallelogram is going to be a quadrilateral with both pairs with both pairs of opposite sides parallel. Okay. The book often will use a picture for parallelogram, so you can do that to represent a parallelogram, and instead of writing the word or instead of writing how I write it like this. If you want to just use the symbol, that's great, okay? So in a parallelogram, we would say, if this is our picture, let's say this is A, B, C, and D. If both pairs of opposite sides are parallel, make sure that when you label it, that you use separate markings, right? So we would mark the first one's parallel with one set of arrows, but then to mark the second set parallel, I can't use one set of arrows, or we're saying they're all parallel to each other, which is not true. So you use 2 pairs of arrows there. And we would say BC and AD are opposite sides, and AB and CD are opposite sides. Give me opposite angles. Which angles would be opposite angles? A and C are opposite angles, and then angle B and angle D are opposite angles. Okay, so you're going to deal a lot with opposites in parallelogram stuff. You're also going to deal with consecutives, and these are ones that maybe you haven't thought about before. So if I said consecutive angles, okay, in this picture above, could you tell me 2 consecutive angles? What does it mean to be consecutive? Like if I said for 3 consecutive years, what am I saying?
3 years in a row.
3 years in a row, right? They follow one right after the other, consecutive. So consecutive angles here would be like angle A and angle B. Right, are consecutive angles. One is right next to the other one. Or I could say angle A and angle D are consecutive angles. Or I could say angle B and angle C are consecutive angles. So if they're next to each other, they're consecutive. If they're across from each other, they're opposite. Okay? Okay, all that to say, we have, let's see, 1, 2, 3. Yes, 3 theorems, but rather than write them as 3 separate theorems, I'm going to write it as one big theorem with 3 separate parts because they all start the same way. So I don't want you to have to write the same thing at the beginning over and over and over again. So I'll show you which one is which, but they all start the same way. So this would be theorem 6.3, 6.4, 6.5. I'll show you which one is which in just a minute. But it starts like this. If a quadrilateral is a parallelogram, then ... and here's our 3 separate theorems. Okay, so they all start with this, and then the first one says that opposite sides are congruent. Okay, so if a quadrilateral is a parallelogram, in other words, if I have this setup where these are parallel and these are parallel, then we also know that opposite sides are congruent. So the thing I would know in this picture is these two sides are the same and those two sides are the same. Okay, so that's the first one. Opposite sides are congruent if it is in fact a parallelogram. Okay. The second one, we're going to be Christmassy right now. The second one says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay, so if we look at a picture of a parallelogram, and this is A, B, C, and D, it will always happen that angle A plus angle B will equal 180, right? That's supplementary. Angle B plus angle C will always be 180. Angle C plus angle D will be 180. And angle D plus angle A will be 180. Okay, so every pair of consecutives, every pair of one right after another will be supplementary. Does anyone see why? What kind of angles do you get from that? They're same side interiors, right? If you have parallel lines and a transversal, the two that are on the same side of that transversal inside the parallel lines are supplementary. Okay, so those are same side interiors. So that's not really new. You've seen that before. We're just thinking of it in terms of parallelograms now. But you have same side interior angles with that. Okay, and then the third theorem, instead of dealing with the sides, deals with the angles. And this one says if a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay. So if this is my parallelogram, you could, you know what, just use the picture you already did. I'll draw it the same way. Okay, so same picture, the green picture, if you want to just use that one, that's fine. It's saying opposite angles are congruent. So our opposite angles here are angle A is congruent to angle C, and angle B is congruent to angle D. Okay, and that really is the gist of what you're going to do with today's lesson, is just taking opposite sides and setting them congruent, opposite angles and setting them congruent, and consecutive angles and setting them supplementary. So I'm going to give you a couple examples of those, and then we are done. Short lesson. All right, let's say we start with this picture. Okay, is that a parallelogram? It is a parallelogram, right? Because opposite sides are marked parallel, so we know it's a parallelogram. And we just learned in a theorem what about the sides of a parallelogram? Opposites are congruent. So here's my question. You have x's and you have y's. Which should you start with? The x's. Which ones? Right, so you want your opposite sides set equal to each other, right? If opposite sides are congruent, then we're going to say that 2x plus 6 will equal 3x minus 2 and solve for x. So we're going to solve here. Take away your 2x, you're left with x, add your 2, you get 8. Okay, so x is 8. How can I figure out what y is? If I know x is 8, how can I find y? Right, so we're going to substitute this 8 right here, right? We know y equals 4x plus 1. So that means y equals 4 times 8 plus 1. So 32 plus 1 would make our y 33. Okay, so x would be 8, y would be 33. Questions on that? Okay, last thing then. Sorry, were you still going there? Let's say we have this parallelogram. And I tell you that angle B is 71 degrees. Okay, I want you to find for me A, C, and D. Okay, so find the 3 missing angles if we know angle B is 71. Where do you want to start? There's no wrong answer here. You can start wherever you want to start. Start at A. Okay, so how would you find A? What'd you say, Leslie? Supplementary, right? So consecutives are supplementary. Okay, so you would just do 180 minus 71 to find the measure of angle A. So you would get 109 for this angle. Okay, what's the measure of angle D going to be? D is the same as angle B, right? Those two are going to be both 71, or again, you can do supplementary to angle A. 180 minus 109 is 71. So what is angle C? 109. So in every parallelogram, you will have 2 angle measures. Now, that's if they haven't drawn in diagonals and whatnot. We'll get there eventually. But for now, opposites are congruent, consecutives are supplementary. So you'll have 2 that are the same and the other 2 that are the same. Okay? Any questions on that? All right, that's really what you're doing today, is just that short lesson.